okay, and then we use our for to print, to assign it the value to our pointer. Okay, so we say our I is equal to 0 as long as I is less than L. Okay, I plus plus. Okay, so I think you know this syntax already. So what I'm going to do next, I will say it should return at the end A. So what I'm going to do next is just say A at index 0 I, like that, and it's going to increase. Then I'll assign it the value of minimum, and then I will say minimum plus plus. Alright, so what I'm doing here is that we need to create an array here, right? So we're creating an array, and then we declare the pointer to that array. Okay, so we are creating an array that will contain the minimum. Okay, that will contain the minimum. Okay, and then we are giving a maximum number. So let's say we have a number 5, we have minimum 2, right? So we have to print the minimum excluded from the maximum. So if we have 5 numbers, this ones we have probably 3 numbers, right? So by the time you minus 5 minus 3, you have 2 left. Okay, you have 2 left. So 2 and then 2 and then plus 1 for the null, so we have 3. So L will be 3. So this one would only go 3 times, right? Because L is 3, it would only go the amount of L times, right? And then we are printing from the minimum. So the minimum can be large, but the thing is, it will not go more than that 3 times out of that minimum. I don't know if you get. So basically, even if this guy is 1, for example, the minimum is 1, right? The minimum is 1. So we want to know, okay, the minimum that is not here is just 1. Okay, so this guy will be 4. So we want to print 4 value out of this minimum. So that's what we are doing. So minimum cannot be greater than maximum. If it is, it will be null, because if maximum is 2 and then we want to subtract 5 from it, we'll be having a minus, right? Which means that we are going to overprint. So minimum has to be small. So that you can subtract what maximum has of minimum, and then the rest you print it out of minimum. Okay, so it's just like this one contains red balls, right? This one contains yellow and red balls. So we'll subtract all the red balls here. So the remaining yellow balls that is here, we'll print it out. But we are not printing everything out. We are printing based on the deduction we make here. Okay, if you calm down and go through the code very well, you would kind of understand what's going on. So let us just check this code and see. So Betty number 3. No description for max. Oh, sorry. Do we have a max? VI. Yes, we used max, so minimum and maximum. Oh, sorry. I didn't. Why am I making mistakes here? Alright. Alright, so let us clear it and compile and see what's going on. So if we try to compile, so let us execute it. So we have this, and then I think we're right. So we git add, we git commit, and what should be our commit message? commit message should be that we are creating array of integers. So let us check our code. Right, and good. So we have 2 more left, I guess. So while this guy is waiting, let us continue. So this guy will not waste our time. So we have a prototype here, right? So via main.h, insert mode, paste this guy, escape from the matrix. Alright, so this one has checked and we're good. So what we do next is write a function that allocates a memory using malloc and free. So this one is going to be a bit longer, right? So we'll be freeing the memory after we've used it. So in order not to waste our time, okay, let's create this guy, 100 main.c. Okay, and then we place this guy here, and we have this. Okay, so sorry, I don't even need to clear it yet. So go to our git now, and then what's the name of the executable for this guy? It's called 100 reallocation. So this one is the reallocation function. Okay, I think this one is quite simple. Reallocation is just probably you allocated the memory and then it's not enough, so you want to increase the memory you allocated, so you could just multiply it by 2 or something. Okay, so the next thing I want to do is create the file. Good, and then we'll get the prototype. This prototype is too long. Okay, why? So we include our main.h, we include our main.h, we include our stdio standard library .h. Why are you doing mistake? Good, and good. So the next thing we do is our documentation. Alright, and then the name is underscore reallocates, realloc. Pointer to a memory. Okay, then we have reallocate, we have pointer. So this pointer is the former pointer to the old memory allocated by malloc. Okay, and then this other one is old size. So the old size is the old size allocated by malloc in the heap, and then this new size. This one is the new size allocated in by the reallocate function or realloc function. So it's going to return a pointer to the newly allocated memory, which will be larger, which is supposed to be larger, right? So with this, I hope you understand what we're trying to do. So basically, a malloc would have a size and a pointer, right? So we just want to increase the size. So we have the pointer before, okay, and then we can just use this pointer to direct to our new pointer that we'll be creating. So we'll transfer everything and increase this size with this new size. So it will collect so this reallocation will collect the former pointer so that you can access it. It will collect the old size and then the new size, right? So this is how it works. So the next thing we're going to do is, okay, let me quickly save this thing because my data is giving me warning. So let me reopen it. All right, good. So sorry. All right. So the first thing we will do, we'll declare a pointer to the new memory that we'll be allocating. So we'll have an unsigned int. So we'll use our size t. Okay, we'll use our size t, and then we'll have I, right? Then we'll have a maximum, right? And then our maximum will give it the new size for simplicity. New size. Okay, and then we'll have a character pointer. We'll call it old pointer. So we just want to rename our old pointer, which is our PTR, for simplicity as well. All right. So the next thing we will say, if our PTR, that's the old pointer, is null, right? Is equal to null. That means it's either it wasn't properly allocated or there's nothing inside before. So if there's nothing inside before, it means that we don't need to reallocate a new size, right? So we can just say our p equals to malloc. So we allocate if our pointer is null. Let me see. Okay, where PTR is a pointer to the memory previously allocated by malloc. Okay, so old size is the size in byte of the allocated space for PTR, right? And new size is the new size in bytes for the new memory block. The content should be copied to the newly allocated space. Okay, the content will be copied to the newly allocated space. So the content of PTR will be copied to the newly allocated space if the range from start of PTR up to the minimum of the old and new size. So if new size is greater than old size, the added memory should be initialized, right? And if they are equal to do not do anything and return pointer, because it means that we are still allocating the old size, so there's no point reallocating. So if PTR is null, then so this is where we are, then the call is equivalent to malloc new size for all value old size and new size. Okay, So we should do this. Okay, so if new size is equal to 0, if our new size is 0, the pointer is not null. Okay, then the call is equivalent to, so we should free the pointer, and then we should return null. Don't forget to free pointer when it makes sense. All right, so that's what we want to do. So we said this one we should do what? We should do new underscore size. Okay, and then we'll return our pointer, which is p, our new pointer. All right, so that's that. So we have so many conditions. So we'll say else if our new size, if our new size is what is equal to 0, then what should we do? Then if our new size is equal to 0, then we should free our pointer, right? That's what we're told. We should free our pointer, and then free pointer, and then we should return null. Then we should return null. Okay, good. So that's that. So we have another condition, else if our new size is equal to old size, right? So else if our new size is equal to old size, then we should do what? We don't need to, we should just return null, right? So we should return, which return, let me see, we should return the old pointer. We should return PTR, right? Okay, so we can still say we should return old P, old pointer. Well, let's use this guy for now. All right, so let's go to the main bulk now. So we say we then allocate memory. So malloc for new size, we allocate memory for new size, and we'll check if that memory is really allocated. So we'll say if our P is equal to null, right, it should return null. It should return null. Good, fine. So if our new size, is greater than old size, yes, so this is the right condition where we need to do that, right? Then we should set our max. Our max is our new size, right? Which is new size. So our new size is equal to old underscore size. Okay, so we are giving assigning our old size to our new size here, and then we'll do a for loop here to transfer whatever is in our old size to our whatever is in our old pointer to our new pointer. Okay, so we'll say I is equal to 0, I is less than max, which is our new size, right? So, and then we'll say I plus plus. So we'll say P at index I is equal to old P at index I. So our new P at index I, we are giving it the value of this guy, so it's going to continue until it's exhausted. Then at the end we should free that old P, right? We should free that pointer, because we are not using it again at the end, and then we should return our new pointer. Betty 100 reallocate.c. Okay, we are good. So let us compile and see. If we get all these guys. Alright, OX02 100 reallocation. So we had this guy error. So it says that we should have comma here, double yes, we should have true. EP is equals to this. So if we add these two, I think this guy will disappear. So let's go. Where is it? Yes, this guy. Why did Betty didn't inform us? Okay, let's see. Let's clear it. Okay, left and yes. So let's go git add git commits reallocate memory from an old one to a larger one, and then git push. So let us check. Sorry, and so we start the test and okay, so we are good. And then the last one. So the last one is always the trouble of all. So this last one is kind of lengthy. So you say we should write a program that multiplies two positive numbers, right? So if you check the execution, you see that the positive numbers they pass are actually a command line argument, right? So we are going to be using the argv-axc, right? So this one, if you now look at this guy, they passed a very long number with this guy. Look at, we are multiplying these guys. Can you imagine? We are multiplying this guy with this guy. So we can't use the normal multiplication because it will not, our normal stuff will not hold value for this. Though we are using malloc to allocate memory, right? And then still we have to use another method, alright? And that is the long format method of multiplication, the one we do in your normal school, in which you do for example, let me clear, and then you do 111 times 222, for example, and then you then do 2 times 1 2, 2 times 1 2, 2 times 1 2, okay, 2 times 1 2, so like that. So one will multiply everything, or you use this one to multiply everything, use this one to multiply everything, use this one to multiply, and then you add the sum together. So basically that's what we'll be doing here, and let's get to it. Okay, so for this guy, it's going to be a bit long, so I'll try and type as fast as I can. Okay, so let's just go into it. So I'll be explaining later. So if you look at it, we were not given that much of a prototype, but they said we should use num1, right? We should use num1 and num2, mul, blah blah blah. This one will be passing base 10, that is, it is an integer, right? Print the numbers followed by a new line. Okay, you should print all the numbers followed by a new line. If the number of argument is incorrect, print error. So we have only 2, so if it is more than 2 argument. Okay, we should print error. So we have 0, 1, 2. That's 2 in the 3 indexes, right? Followed by a new line, and then exit with a status of 98. Okay, num 1 and num 2 should be composed of digits. If not, print error. So all these things, I'm going to create different functions for them, and then you're allowed to use more than 5 functions. Okay, so we can use up to 5 different functions in the file. You get? Okay, so let's get into it. So I'll just create my 101, and then I'll just continue coding and explaining, and then we'll check our code. All right, so this guy, any executable, 101 mul. So let me first vi our dot git ignore. So when I'm done, I would add the prototypes I created. Okay, so alright, so I'll vi 101 mul.c. right, so I'm going to include our main.h because I will still be adding the prototypes to our main.h. I don't know what prototype I'll be using right now, so I'll be adding it last. Alright, so you guys should remind me in case I didn't put it. Anyway, you won't be able to remind me because it's not a live video. So std standard library.h. so I'll put my include stdio.h. okay, so we are going to include one more stuff, which is a macro this macro something, I've forgotten the name. So we are going to that one we say define. Okay, so we want an error message, right? We want to define an error message. Okay, and we want to call it error. So what this guy does is that anytime we press error message, it's going to produce error for us. So don't worry much about this one. So let's go into our code. Okay, so the first one is we'll create a function called isDigit. We've done that before to check if a string contains only digits, right? So we'll be using it in our main functions because we are using our main as command line argument. Command line argument is to a main function. Okay, so we'll be the one to create the main. All right, so we'll say int, right, or sorry, isDigit, right? So it's going to be, you can say is underscore digit, right? And then we'll say this one will check if a string contains a non-digit character, and then we'll have at s, we can give s, which would be the string to be evaluated, right? So we'll have our return. So our return should return probably 0 if a non-digit is found, and 1 if digit is found. Alright, and then we'll end it that way. So the first function of the day, right? So I can just give this place a space so to differentiate from that guy. Alright, so this one is going to return an int, okay, because it's 0 or 1, right? And then we'll create the function is underscore digit. Alright, and then it's going to collect a parameter of character. Okay, a character, a pointer, probably a pointer s, right? And then we do this. Alright, so we'll say that, what's this fly? So int I equals to 0. We'll set our int I equals to 0, and then we want to use a while loop, right? So we'll say while good, and at the end it should return, this one should return 1 at the end. Okay, so while our s, because we are dealing with string at index I, okay, and then at the end we have, inside we have our I plus plus. We can use our for loop as well, I plus plus, right? Don't forget to put semicolon here, and then good. So what are we going to say? We say if our if doesn't have this guy, then we'll say if our s I is less than the value of 0, that is, it is not 0, less than 0, anything less than 0, or if our value of I, okay, is greater than 10 or greater than 9 rather, okay, then it is not a digit, okay. Then if all this is, it should what? It should return 0, showing that it is not a digit, or else it should just return 1, showing that it is a digit. Okay, so that's the first function. So we'll create up to probably 4 functions. Okay, we create 4 functions. So the second function we'll be creating is a string length function. We'll create a string length function, and then we'll call that, sorry, we'll say underscore string length returns the length of a string, right? And then we have our s, which is the string to evaluate, and then it's going to return an int, right? Length of the string, right? It's going to return the length of the string. So we have our int string length, right? Sorry. So we are declaring a function for this guy. So it's going to be a character as well, character s, and then we have our function to play with. So in our function, we'll initialize int I to be 0 as well. And then we'll give space here, we'll use our while loop as usual, and then enter, do this, enter. Okay, at the end it should want to return our I, because I will be holding the string length, right? So this place will have our input tab here, our I plus plus, and at the top we'll have our condition. No, we don't need to have condition here, we just have condition inside this place. I will say as long as s at index I is not equal to none, right? As long as this, it should keep increasing I, right? And then this function will help us get the string length. So we have 2 more functions to go, and then the next function is going to be the function that will help us just print error. Okay, and that one is a very short function. So we'll create this, and we'll document it, and we'll say errors, the errors function. Okay, so the errors function will undo error of the main. So it's not going to have any parameter, so we don't need anything. Alright, so we'll just say it's going to return a void and then error. Okay, so we just do the error, close and open and close bracket, and it should print error out for us. Sorry, it should print error out for us. So we'll just say print f should print error and a new line, right? And then at the end it should exit 98. I think it's 98. Okay, and that's all. So the last function, which is the main function that will be created, we'll then say this. Alright, then we'll say the main. So this is our main function. So we have our v and argc here. So this one is the one that will multiply two positive numbers. Okay, so we have our argc, which is the argument count, and then we have our argv, which is the argument vector, and then it's going to return, definitely it's going to return a probably int, right? Let's just say it should return 0. Okay, it should return 0. Alright, so we have our int main, right? Argc, alright, argc is an int, so int argc, and char is argv, char argv. I hope I didn't misspell it. And then this one we can do it this way, right? Alright, so good. So for this guy, I hope time hasn't gone. Time is going. Okay, so let's be fast with it. So the next thing we're going to do is we'll declare some variables that we'll be using. Okay, so we'll say our char s1, that's the first value, that's the first number, and then we'll have pointer to s2, and then we'll have an int for the length 1. We'll have our the length of the second one, and then the total length, and then we'll have I, and then we'll have a carry. This one is, when you are multiplying 2 times, let's say 2 times 10, that's 20, you write 0, remainder 2, so the carry is the remainder. Alright, so we'll have the digits that will hold each digit that we want to, so we'll have digit 1, and then we'll have our digit 2 that will hold the second digit to multiply together, and then our result, which will be the one holding our result, it's going to be a pointer, and then we'll have an a to be equals to 0. Okay, so I think that's all for now. Alright, so the next thing we're going to do is we'll check s1, we'll assign it to argc, argv. Let's give s1 argv, that's the number itself, right? So give s1 argv and argv at argv1, right? Yes, and then remember is the vector that we need, so we'll just do that, and then we'll say our s2 is the second number, so we'll give it arg v at index 2. Remember that arg v at index 0 is the command name, is the execution name. Alright, so we'll have that. So we then say that if our arg c, right, if our arg c, the count, is not equal to 3, so we can use this guy to actually manipulate the numbers, because arg c is the number, right? If it's not equal to 3, right, or it has to be 3 for us to multiply. If it is more than, it is problem. So we'll use our is digit function, is underscore digit, right? So we'll use our is digit function. So we'll say that if our s1 is not, as you can see we have not, is not a digit, okay, as well, or if our s22 is not a digit, is digit, right, s2, right, if our s22 is not a digit, then what should happen? It should print error. So we just call our error command, and then error, and then to exit 98, right? So this guy will fix that for us. So the next thing we'll do is we'll initialize our length 1, right? So length 1 will help us get the length of our s1. So we'll just pass it the value of that string length, string len, sorry, and then we'll have our s1, and then length 2 will be equal to string length of s2. So we'll have our length, which will be length 1 plus length 2 plus 1, which is going to be the null, right? So then we'll have our result, okay, and then what we'll do to our result is we'll allocate space for results. So we'll say malloc, and then we'll say want to allocate space for this. It's going to be size of an int, right, multiply by the length, okay, multiply by length, and that should allocate for the stuff. So we'll check if it worked. So we'll just say if not result, if what we have is not result, right, it should return 1 as a failure, right? Okay, good. So if it is, then we want to do our for loop. Then we'll say for, and then we'll say for I equals to 0, okay, I is less than equal to len 1, right, and then plus, okay, len 2, I plus plus, okay. So this is what we'll do, and then results of so what we do is, as long as I is, we want to iterate through the length, right? So the result at index I, so the results at index I, we are initializing it with 0, okay. So everything at result at index I will go from 0 to the length of the string, okay. So everything in the result is 0 for now, okay. So that's what we did. Yeah, so we'll then say so this guy is quite long, so we'll say for, okay, and then we'll say our length, right, is equal to len, or we'll say for our length 1 is equal to length 1 minus 1, okay, and our len 1 greater than or equal to 0. So I'll explain this one to you, and then we'll have len 1 minus minus. So for example, if our first length, okay, so if we have 572, right, we want to multiply 572, let's say we want to multiply this 72 by 42. So what we want to do, we want to start from the last number 2 to multiply 2, and then 2 to multiply 4. So that's what we do for the first length. Okay, so we did the length minus the null first, right? Okay, so the length of that, then we are decrementing it down, so it's going to be picking up these guys one by one from behind. Okay, so that's what we are doing to this guy. So we press enter. All right, so len minus minus. Okay, so we'll do our this guy. So we want to multiply it with the second one, right? But before that, we then do some stuff and say digit 1 is equal to s1 our len. Okay, and then we want to convert to whatever is inside to a number, a valid number. Okay, so we want to use a number, we don't want to use ASCII value. All right, so what we are doing is, since len 1 now is equals to the last number, okay, so we are giving this digit 1 the last number in order to multiply with the last number of the second value that we have. All right, so that's what we are having for now. So we are passing the last digit of this guy to digit 1. Okay, so the next thing we are going to do is we'll say the carry, right? So carry, so we want to be accumulating the remainder to carry. Okay, so carry results, and then len 1 plus len 2 plus 1. Okay, so what this guy does is that we have our length 1, we have our length 2, we have plus 1. Okay, so what we do is we say that len 1, we say that len 1 plus 2, so this guy is just an array. And remember that results, if we add this guy together, is we are going to get len 1 currently is probably what's it called, we are going to get what's it called, the length of that string, of the total string, right? So what we do is we initialize it to 0. Okay, so this one is still 0. Okay, so 0 plus, then we'll then multiply our digits. Okay, so okay, I think we've gone too far here. Let me see. Digit 1 is equals to, okay, sorry, I think that person, I got messed up. So the carry, we still set it to 0 here. Yeah, let us set our carry. So we've not started adding, so we'll have another for loop, and then this one will go for our second digit before we start multiplying. Then we'll say our len 2 also with the same thing. So our len 2 is equal to the string length is equal to the string length of s2. We know that already, so let me just pass it. minus 1, or is equal to len 2 minus 1. So let us just say is equal to len 2 minus 1. Okay, and then the next thing we do is we say len 2 as far as it is less than equal to 0, like we did above, and then len 2 minus minus, then we'll close our for loop. Okay, and then we'll say our digit 2, we'll pass it the value of this guy. We'll say s2, right, at len 2. So pass the last digits as well, and then we'll minus 0. Alright, so this is what we do. And then the next thing we do is we then do our carry. So basically what we are doing is we are getting the last digits of both, and we are giving it to digit 1 and digit 2, so that we can multiply those last digits and give the remainder to this guy, and then we'll continue for that. Like the last of this one will multiply all the value of this one from the last to the beginning. That's why this thing is minus minus, right? And then we are starting from the highest. Okay, so from the last to the beginning, and then the carry would add up to itself and add to the front. Then we'll do the same thing for all these guys, and then at the end we add them together and print it out. So basically that's what we want to do. So let me just try and code everything, because and explain as once I'm done. So I'll say carry plus equals to what I was saying before. So this is what I did here is okay. So carry is still holding the result of the last two digits, right? The last digit of the first one and the first last digit of digit 2, right? So digit 1 is probably, let's say it is 9. Yeah, 9 times probably. Okay, let's say digit 1 is, we're using this 2. Digit 1 is 8. So 8 will multiply 4. 8 will multiply 5. So 8 is multiplying 4, and we are giving it to this guy. So this one is just the index, the position of where it is. Okay, you know that when you are doing this guy, it has to be at a particular position. So this one is just the position. Okay, and we set all those positions, the value to be 0, so they are not interfering with the value of this guy. Okay, so it's still 0 that is multiplying it, but we know that it's a position here. All right, so we are giving it to carry. This my result is not correct. Digits will plus digit 1. Modulus 10. tries to carry it should be like this. Okay, good. Okay, so we are done here, and he said we then, this one we've gotten the total we've given it to carry. So at that position now, we are saying that carry modulus 10. Okay, modulus 10 will give us the last number, right? So we are putting the last number here, and the remainder we are giving it to carry. So it will continue, and then it's going to continue, and then would add up carry later, which is the remainder, to the next iteration. Alright, so I think that should solve that. So when we are done with the first iteration, or with all the iteration, okay, so we then say if our carry is greater than 0, okay, the result that we are getting should then be at length 1 plus length 2 plus 1 should be added to carry. Okay, so we have the result of carry there, and then we'll end that. So I think that's that. So I think we are done. So the next thing is for this guy, let me just close this braces. Let me give this guy a brace. This is 0.4. Okay, good. But this guy has to be minimal. Okay. Alright, so I think we are good like this. So we then create, so it's now time to print. So that's what we want to do now. So we'll create a for loop. And then at the end of the for loop, okay, I want to see if and if statements, and then we'll use our underscore put char here twice. Underscore put char. Free, and we should return 0. So this is where we are ending. So let me just fill up these guys and see. So we are freeing results once we've printed out our results. So this one is just a new line at the end, okay, and then this one is just a null, a 0. Okay, if it is not a, right, so understand what a is at this top. Okay, so this place we'll then do our for statement and say I is equals to 0. Okay, I is less than length, so we want to print out what is inside length. Okay, I is less than length minus 1. Okay, and then we have our I plus plus. Alright, so codes like this, there are going to be a lot of mistakes, but let's see. So then inside our for loop we have two if statements. We have if statement. So if our result index I, then it's going to print a equals to 1. Okay, and then if it is a, then it should just print the result at index I, convert it to number. Okay, and I think we are done like this. So the next thing is we need the prototypes, right? I think the prototype of this one is simple. We copy it this. Alright, so we need 3 more prototypes. Void error string length. So I can just do like this. Hey, I'm going to paste it. I told you to paste it. Let's just go one by one. Copy. Sorry, let me just do the void error. Which means 1 more. So return void error. Return is digits. So it's just string length. So that was Betty 101. Exactly, we should have a dot. No description form from function error. Really? So VI1. Okay, I wrote errors. Okay. And what else? Parentheses are required on the return statement at 22. It's 22. Okay. We didn't put a semicolon. Okay. And then 44. Void error should probably be void error. Void. Okay. 44. Say that we should use void here. So let us repeat it. So battery, so we are good now, and compile. We have errors. Okay, we now have put. So we need put from CD into OX05, for example, right? I should have put here. Yes, so I will copy my put and then I'll paste it where in my 0x0c. So I'll go back to my 0x0c. So I should have my put channel. So let me recompile. A lot of error. Okay, so okay, we have to put function as well. Our main.h. So let us clear. And see, okay, the error has reduced. 6736. 6736. So what is it for 101? So 67. Yes. We have a semi colon here. Let us recompile. Okay, now reducing it. 9614. 9614. Strength number 26. And then let me clear it and recompile. Oh, recompiled. So 101 error. So we have an error, and that's not what we are supposed to have. So let's check. Okay, no. We have an error because we didn't pass an argument to it. So let's pass this argument. Okay, we have just a comma instead of 980. Okay, so let us check and see where the main mistake lies. Alright, so we go through it. Let's see. So I think the mistake should be from, okay, let me check from this top. Main.h, stlive.h, sth. Alright. This digit chars int I, wireless is I, if s is less than 0, s is 9. We've done this. I plus plus, correct. So string length int I, si equals 0, I, yes, return, yes. Error, gi. So I'm using error. So normally I think I used errors before, but it doesn't matter. So you should print error. Good. S1 and if argc is 3 is digit 32 error, right? And then length 1, length 2, length 1 is plus 1, result is malloc size of 8 times n. Okay, should return 1. For I equals 0, I is less than or equal to then 1 and 2. Right. So let me open a parenthesis here. Or let me close it. If I equals to 1 for I equals to this, equals to this for digit 1 equals to s, carry equals to 0 for and 2 equals to string length of s2. Let me just use this one as string length of s2 and see. But I think it's still the same thing. Okay, -1. Yes. Digit 2 s2 length 2 minus 0. Carry plus result length plus digit 1 times digit 2. Result length 1 plus length 2 plus 1. Carry percent 10. Carry 10 close parenthesis. If carry is greater than 10, then length 1 plus length this plus this equals to carry, and then close. For I equals to 0, I is less than length minus 1 I plus plus. So if our result is I, A equals to 1. If A, put char result I plus 0. If not A, put char 0. Okay, let's see. Let's recompile and see. We have to. Anyway, let me just git push and see. Git add, git commit, test, git push. Okay, so let us check. I'm sure there's a mistake we are making somewhere. So this one should not check, definitely. It shouldn't. We're making a mistake somewhere. So why that? Let me clear my screen and go back into it and check one more time. So if I didn't see this, I'm going to probably check the correction and share it with you guys. Page up, home. Alright. It's supposed to be done by now. So what's the error? Just this. Okay, no details yet. Okay, so what we're gonna do is we'll check it one more time and we'll see if we are right. So define error message is digits s int I while s is I, string length I equals to 0. Correct. So let me just use errors for this guy because that's what I used initially. Errors void int error. It does. Oh, sorry. Why is it not deleting? Error is okay. Well, I'm not sure that's the problem. And continue. Which means we learn to result because some of size of int times n equals done for then 1 for I equals 0 for then 1 equals to then 1 minus 1. Then 1 is greater than or equals to then 1 minus minus s1 carry equals to 0 for. So which one is result? Okay, let me check my mail notification. Okay, let me compile it and see. Okay, let me see. And 98 and 10. Okay, it worked. So I don't know. Let's go up again. So I checked through, and this is what I had. Okay, so I used the errors. That's not the issue. I just rechecked it and um, so this is everything. Okay, and let us git add git commits. So let us check. So I think this should work since we've been checked. Alright, so that will be all for now. We might have a class to kind of clarify this task. I think it's getting crazy, especially the last one. The last one is always much and tedious, so it's prone to error. Alright guys, I'll see you. Bye.